Dear class 10 student, welcome back. We'll continue periodic classification. We have done up to Mendelic's periodic table. Today we will be doing modern periodic table. Let's go to modern periodic table. Okay, making order of out of chaos, the modern periodic table. Okay, arranging elements in arrangement of elements in modern periodic table. Okay, so Henry was the person, the scientist who discovered the modern periodic table and showed that atomic numbers symbolized as Z of an electron is more fundamental property than its atomic mass. Mendelic periodic table was based on atomic masses, but according to modern periodic table, elements are arranged according to their atomic number. So atomic number is what? Atomic number is the number of proton in the nucleus. Okay. So Mendelic periodic table was modified and atomic number was adopted as the basis of modern periodic table, and the modern periodic table can be stated as follows. So properties of elements are periodic function of their atomic masses. What is, if somebody asks you state modern periodic law, then you will write properties of elements are a periodic function of their atomic number. Okay, now let us recall that atomic number gives us the number of protons in the nucleus of an atom, and this number increases by 1 in going from one element to the next. So according to if equation is there, define modern periodic table, you write like this: elements when arranged in order of increasing atomic number lead us to the classification known as the modern periodic table. Prediction of the properties of the elements could be made with more precision when elements were arranged on the basis of increasing atomic number. Okay, now here is the periodic table. We can see it here. Okay, this vertical columns are the vertical columns are called group. So how many groups are there? 1, 2. In modern periodic table, this vertical columns are called groups. Okay, so how many groups are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there are 18 groups in modern periodic table, and these rows, this are the rows. Okay, these are the rows, and these are the rows. So when we go from left to right in a row, this row are called periods in the modern periodic table. So there are, how many rows are there? The periods are there. 1, 2, 3, 4, 5, 6, 7. 7 periods are there in the modern periodic table. Okay. Now position of element in the modern periodic table. We'll find out the position of element in the modern table. The modern periodic table has 18 vertical columns known as groups and 7 vertical rows known as periods. So question is this: what are groups and periods in the modern periodic table? You'll find that all these elements contain the same number of valence electrons. Similarly, Similarly, you will find that the elements present in any one group have the same number of valence electrons. For example, elements with fluorine and chlorine belongs to 17 group. So how many electrons do the fluorine and chlorine have in their outermost shells? Hence we can say that groups in groups in the periodic table signifies an identical outer shell electronic configuration. On the other hand, the atomic number of shells increase as we go down the group. So let us see again. When we go down the group, here outermost orbit have one electron in the first group, one electron. All these elements have one element in their outermost shell, and in the second group all the elements have two electrons in the outermost orbit, or outermost shell. Similarly, here 3. Now, so when we go down the group, number of electrons electrons in the outermost orbit does not change, but the number of shell increases by 1. For example, hydrogen has only one shell, K shell. Lithium has K and L. Okay, K and L. For example, let's see here. So if we increase it, for example, if we take hydrogen, how many electrons are there in the outermost orbit? Only one. So this is only one electron. Lithium has, so first K shell can accommodate only 2 electrons, maximum 2 electrons. So helium has, okay, now in the periodic table, second is lithium. So let's go to lithium, draw the electron configuration of lithium. It is, atomic number is 3. Okay, so it will have 2 electrons in the K shell and 1 electron in the L shell. So its outermost orbit has 1 electron. Hydrogen has also 1 electron and lithium has also 1 electron, but the number of shell increases. It is in the second shell, means L shell. Now let us go to sodium. Sodium, it is 11, atomic number is 11. So okay, so it has 11 atomic number. So first shell will have 2 electron, in the second shell, in the L shell, there will be okay, 2, 4, 5, 6, 7, 8. So in the second shell, KL shell, there is 8 electron, but even that now even the number of electrons are how much? 10. So 1 electron will be in the anywhere in the M shell. Okay, so outermost orbit has sodium also have one electron in the outermost orbit. So let us consider the periodic. So as we go down the group, number of shell increases by 1, but number of electrons in the valence outermost orbit is 1. Okay, it does not increases. Here number of shells are increasing. If you go down in the second group also it is increasing, but number of electrons is 2 in the outermost orbit. Okay, for example, it can be either in group 1 or so in your textbook fluorine and chlorine is considered. Fluorine has atomic number 9. Okay, let us draw the electronic configuration of fluorine. Now take it, fluorine, it is atomic number is 9. And so 2 in the outermost orbit. Okay, see here, 2 in the outermost orbit. Let's cut this one. 2 in the outermost orbit, and 7 in the 1, 2, 3, 4, 5, 6, 7 in the outermost, 7 electrons in the outermost orbit. So it has 7 electrons. So in the periodic table, fluorine, chlorine, bromine, iodine, all these are in group 17. Okay, so now chlorine, let us take the atomic number, consider chlorine. Its atomic number is 17. So the first shell, K shell, will have 2 electrons, and the second shell, that is L shell, will have 8 electrons. Anywhere here. So 8 electrons. Now even 7 electrons are remaining. So in the M shell there will be 7 electrons. One, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So 1, 2 and 8, 10 electrons in the two orbits, and 7 in the M shell, that is outermost orbit. So total atomic number is 17. Okay, so as we go down, number of shell are increasing, but the outermost orbit atomic numbers are not increasing. It is same for particular group. Okay, so we have understood this about group. there is an anomaly. On the other hand, number of shells increases as we go down the group. Okay, there is an anomaly when it comes to the position of hydrogen, because it can be placed either in group 1 or group 17 in the first period. Okay, now in the case of hydrogen, we can place this hydrogen in this group also. In 17th group also, because in the outermost orbit hydrogen has 1 electron. Hydrogen can either lose electron like lithium, sodium and potassium, or it can take electron as like fluorine, chlorine. Okay, so we can place hydrogen in these 2 groups, any one of these groups. Okay, so this is the position, this is the anomaly of hydrogen in Mendeleev predictable. Anomaly of position of hydrogen in Mendeleev predictable was solved in modern predictable. Okay, you will find that these elements of second period do not have the same number of valence electron, but they have contain same number of shells. You also observe that the number of valence shells electrons increases by 1 unit as the atomic number increases by 1 unit on moving from left to right in a period. So when we go from left to right in a period, shell are not increasing. Okay, number of shells are not increasing. Let us consider lithium. Lithium has in the outermost orbit how many electrons? 1. In the beryllium it is 2, and in boron the outermost electron will have 3 electrons. Okay, and carbon will have 4, nitrogen will have 5, oxygen will have 6, and fluorine will have 7. So at number of electrons are increased, number of shells is fixed. Neon, it is outermost orbit will have 8 electrons. Okay, so when we go across the period, atomic number increases by 1. Okay, but the number of shell remains same. Or we can say that atoms of different element with same number of occupied shells are placed in the same period. So for example, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, they are in the same period. Let us see the periodic table again. So see here, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine are in the same period, since the atomic number are increasing by 1 unit if we go from left to right in a periodic table. Okay, argon, and argon belongs to the third period of the. So this sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine and argon belongs to the third period of the periodic table. Just see, let's see here, it is third period. Okay, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine and argon, these are in the third period. So now write the electronic configuration of these elements and confirm the above statement. Each you can write the electronic configuration of sodium. It will be 281, magnesium 282, aluminum 283, silicon 284, phosphorus 285, sulfur 286 and chlorine 287. the electronic configuration. Okay. How many electrons are there in the first and the second, first, second and third and fourth periods? Okay, we can explain the number of elements in this period on the periods based on how electrons are filled into various shells. We will study the detail of this in the higher classes. We call the maximum number of electrons that can be accommodated in a shell depends on the formula twice n square. So it depends on the twice n square. So n gives the number of shells, where n is the number of given shell from the nucleus. For example, K shell, it will have K is 1, okay, n is equal to 1, K means n is equal to 1, so 2n square, so 1 square, so we have 2 electron, maximum it can accommodate 2 electron, hence the first period will have 2 first 2 element, I mean the first period will have 2 elements, okay. L shell, it will have 8 elements, okay, because 8 shell, n is 2, so 2 square is 4, 4 to ja 8, hence it will have 8 elements. Third and fourth, sixth, seventh will have 8, 18, 32 and 18, 32 elements respectively. The reason for this you will study in higher classes, okay, you will study the reason in the higher class. The position of an element in a periodic table tell us about its chemical reactivity. The position gives us the reactivity of the element. As you have learned that the valence electron determines the kind of number of bonds formed by the elements. Can you now say why Mendeleev's choice of formula of compound as a basis of deciding position of an element in his period was good one? How would this lead to the element with similar chemical property being placed in the same group? Okay. Now trends. We will now study the trends. What are the trends? First is valency. So here valency, when we go down the group, valency does not remains the same. Valency is hydrogen. Valency of hydrogen is 1, lithium is 1, sodium is 1, potassium is 1, and so on. And in the second group, the valency is beryllium is 2, magnesium is 2. So valency remains same if you go down the group. But in case of periods, let's take this third period. Valency is 1, sodium is 1, magnesium is 2, aluminum is 3, silicon is 4. Again up to 4, it will valency will increase. Again it will start decreasing from phosphorus. It will be 3, 4, 3, 2, 1, and argon will be 0. Okay. Atomic size. If we go down the group, atomic size will increase because the number of shells are added if you go down the group. Okay. But in case of periods, number of protons and electrons are increasing. So the force of attraction between protons and will increase. 11. Then for example, sodium have 11 electrons and 11 protons. So, and in case of magnesium, it has 12 electrons and 12 protons. So attraction between the electrons and proton is much more in magnesium. Likewise, aluminum, there is 13 protons and 13 electrons. So it is magnesium. The attraction between the electrons and protons in magnesium is less than aluminum, so on. So due to this attraction, the size of the atom will decrease. So when we go across the period, the atomic size will decrease. You will see that atomic radius decreases in moving from left to right along the period. This is due to the increase of nuclear charges, which tends to pull the electron closer to the nucleus and reduces the size of the atom. Metallic and non-metallic properties. So in the periodic table, you see metals are this, metalloids are pink color and non-metals are yellow color. So these are all non-metals, metals. These are all metals, and these are non-metals, yellow, and these are called metalloids. Okay, so metallic characteristic increases when we go down the group, and here sodium is more metallic than magnesium and it is less than carbon. So metallic property decreases when we go from left to right in a periodic in a period. Okay, when we go from here in a period, if we go from left to right, the metallic property decreases and non-metallic property increases. Here metallic, if you go down the group, metallic property increases but non-metallic property decreases. Okay, so that's all for today. Thank you very much. We'll do the exercises tomorrow or in the next session of this online classes.